I love riding my skateboard. It's the best thing ever. Having the wind through my hair and all the physics involved, it's absolutely amazing. And here you can see a picture of me absolutely enjoying myself. And here's a free body diagram of all the forces acting on me while I'm on my skateboard. There's a force of friction acting against my movement, the force of gravity pulling me down, and the force of normal pushing me upwards.
Don't forget about me. Don't you hate it when you're just trying to learn physics and a pesky skateboarder tries to take your head off?
Forget about that. I don't even know if I'm gonna hit you yet. How about we find out?
The coefficient of kinetic friction is assumed to be 0.05. In addition, the mass of the rider is 60 kilograms. The force of the normal can be retrieved by multiplying the mass of the rider by the acceleration due to gravity. That is 60 kilograms multiplied by 9.8 meters per second squared. Therefore, the normal force acting on the rider is 588 newtons.
But wait, how are we going to use that to find the force of friction? Well, it's quite simple, really. We know that the force of normal was calculated earlier to be 588 newtons, and we know that the force of friction is equal to a coefficient of kinetic friction times the force of normal. Well, the coefficient of kinetic friction is 0.05, so the force of friction is equal to 0.05 times the force of normal, which is 588 newtons. Force of friction is equal to 29.4 newtons.
So now that we know the force of friction, let's just add that to the top. So we know that the force of friction is the only force acting on the rider in the horizontal plane. Therefore, we can equate the net force to the force of friction. So, the force of friction is equal to mass times acceleration. As previously stated, the mass of the rider is 60 kilograms. Rearranging, we can say that 29.4 newtons divided by 60 kilograms will give you the acceleration. Therefore, the acceleration is 0.49 meters per second squared.
But don't forget to make a negative, because acceleration is in the opposite direction of movement. So we know that the initial velocity is 5.0 meters per second, and the final velocity is 0 meters per second. We also know that the acceleration is negative 0.49 meters per second squared.
But what is the change in distance going to be? Do you remember your kinematic equations?
Of course I do. V final square is equal to V initial square plus 2 times acceleration times change in x. We can then rearrange the equation to isolate for change in x. With this in mind, we find that the change in x is equal to 0 meters per second square minus 5 meters per second square divided by 2 times negative 0.49 meters per second squared. Therefore, we calculate change in x to be 25.51202041 meters.
What about significant digits?
Well, with significant figures in mind, we can say that the final answer is 26 meters.
Oh, hey man, what's up? You ready for the physics exam?
Yeah, man, how about you?
Cool, me too, man.
Good luck, buddy.
Thanks, you too, bro. Physics rules.